So this is going to be a quick review of solving equations with distribution, including distributing a fraction. So this is a very simple distribution problem where we need to distribute 5 to the 3x plus 6. So we would do 5 times 3x and 5 times 6. For the sake of notes, I will write out exactly what we're doing here. Typically, if I were solving this on my own, I would just show that I'm distributing it and then write the next. I would skip this second line and I would just go to say 15x plus 30 equals negative 45. The biggest thing about distribution is making sure that you do distribute to all terms and whatever the sign of the leading coefficient is. So in this case, this 5 is positive. We would just distribute that sign as well. It isn't a big deal if it's positive, but if it's negative, you do need to make sure you distribute the negative sign. At this point, since I have constants on both sides, I will eliminate one of the constants. So I will subtract 30. That leaves me with 15x equals negative 75. And then I will make this a 1x by dividing by 15, because 15 divided by 15 is 1. So x equals negative 5. Although honestly, and I don't know if you guys have ever really seen this, here at this point, a lot of people think you have to do the constant first. That's not actually true. So if I have 15x plus 30 equals negative 45, I could choose to make the 15x a 1x first. So I could divide the entire equation by 15. The tricky part here is that you have to remember to also divide the 30. Most people will divide the 15x and the negative 45 and forget the 30, but everything would have to be simplified by dividing by 15, so that would make it x plus 2 equals negative 3. Then if I subtract 2, I would have x equals negative 5. This is not a method that most people use because typically everything is not neatly divisible by that coefficient. This one happens to work out where it is, but again, that wouldn't always be the case. So we want to try to do the method that is the simplest without creating more complicated numbers. Like if we can keep them integer values, that's a lot easier than if we have to move into rationals, which would be our fractions and decimals. Now, when you have a fraction that needs to be distributed, I like to look at the denominator. So here we have a denominator of 3, and I like to look at all the terms inside the parentheses to see if they are multiples of that denominator. So in this case, are they multiples of 3? They are, and that means that if I were to distribute this, I should be able to end up with integer values. If these were not divisible by 3 or multiples of 3, then I might not want to do this method. And so we'll look at a different option here in a second because there is more than one way to do these. Distributing is nice. And so that's what we will do here. We will go ahead and distribute the 4/3. So we will have 4/3 times 9x and 4/3 times negative 3. 4/3 times 9x, I would divide by the 3 first, so 9 divided by 3 is 3. 3 times 4 is 12, so this should be 12x. And then negative 3 divided by 3 is negative 1, times 4 would be negative 4, so this would be minus 4. At this point, we would add 4, because dividing by 12 first here would create rationals, because 4 and 8 are not divisible by 12, so we would want to go ahead and do the constant to 0 first, and so we have 12x equals 12, and then if we divide by 12 to make it 1x, we find that x equals 1. So that's the option of going ahead and distributing it. It's not the only option, so let's look at another one. So with this problem, you can see that 2/7, our denominator of 7, 4x and negative 9 are not factors of 7, are not multiples of 7. So if we were to distribute 2/7 into the parentheses, we would end up with more fractions, more rationals. I'll demonstrate that for you here. This one would be 8/7 x minus 18/7 equals 18. And the more fractions you have, the more likely it is you're going to make a mistake. So if we can try to avoid having all of these different rationals, it would make it a little easier on us. So the other option that I like to do is to eliminate that distribution. So let me rewrite this problem over here. So we have 2/7 times 4x minus 9 equals 18. So if I want to get rid of a fraction, I can multiply by the reciprocal, which would cause that fraction to have a value of 1. So the reciprocal of 2/7 would be 7/2. So if I multiply those together, it would become 14/14, which is 1. I wouldn't need to distribute 1 because it's not going to do anything to 4x minus 9. But if I bring in 7/2 on the left side, I do need to multiply the other side by 7/2. So we'll be multiplying by 7 and dividing by 2. 18 is divisible by 2, so that's actually going to work out really nice, much better than having the fractions on the other side. So we would have 4x minus 9 equals 18 divided by 2 is 9. 9 times 7 would be 63. And then from there, you could just go about solving this one as you normally would. So the key here to deciding if you want to actually distribute that fraction or if you want to go ahead and multiply by the reciprocal really comes down to what's inside the parentheses. If it's divisible by the denominator, go ahead and distribute. If it's not divisible by the denominator, then I would multiply by the reciprocal. So here I'm going to add 9. So I have 4x plus 0, so I don't need to write that, equals 72. And then 4x divided by 4 would make it 1x. Divide both sides by 4. So x equals 18. And that's just a different option. Go ahead and try to solve this one. Decide if you want to distribute or if you want to multiply by the reciprocal. So this one does work very nicely to distribute because both of those terms are divisible by 2. So if you distribute it, you should end up with 3 equals 5x minus 10. And then when you go to solve from there, you should get 13/5 for x. Or if you convert it to a decimal, it would be 2.6. Go ahead and try this one. Again, think about, would you distribute this? Does it distribute nicely? If it doesn't, then would you want to multiply by the reciprocal? So this one does not distribute well since 9x or 3 are not divisible by 5. If you multiply by the reciprocal, however, that would make it 1 times 9x minus 3. No need to multiply by 1. And then 12 times 5/4 would be 15. When you solve from there, you should find that x is equal to 2.